Once again to the Moji Math and Science. In this lesson, we'll look at special angles. I believe at the end of this lesson, you understand how to use your 60 degrees, 30 degrees, and 45 degrees without using calculators. You'll be able to solve for them when you see them in equations, and you understand how to quickly arrive at them. Now, we'll be defining 60 degrees. Let's use an equilateral triangle. We'll use an equilateral triangle to explain 60 and 30 degrees. For my equilateral triangle, we know that all the sides, the angles are equal. If I have 60 degrees here, I'll have 60 degrees here, and I'll also have what here? 60 degrees here. Now, if this side is 2, this side will be 2, and this side also will be what? 2. Let's label the triangle A, B, and C. Since it's an equilateral triangle, if I draw a line here, it will divide this triangle into 2 equal parts, such that this side will be 1, and this side also will be what? 1. And here should be what? A right angle triangle. Now, let's call this point, let's call it D. Obviously, from this part, I now have a new triangle, which should look this way. This is A, here is C, and here is D. Here is 2, and here is what? 1. If here is 60, and here is 90, from my right angle, from my triangle, sum of angles in a triangle, I know that this angle at A, let's call the angle at AA, plus 60 plus 90 must be equal to what? 180 degrees. That's sum of angles in a right angle triangle. So that A, 60 plus 90, that's 150, is equal to what? 180. My A is equal to 180 minus 150 degrees, which is equal to what? 30 degrees. So here we have my what? 30 degrees. Now, if I have 30 degrees here, let's call this side small c. From triangle ADC, we can see that the longer side of that triangle is 2, and from Pythagoras theorem, we can conclude that 2 squared is equal to c squared plus 1 squared. 2, that's 4. 2 squared is 4, is equal to c squared plus 1. 4 minus 1, that's 3, is equal to c squared. So that root 3 is equal to what? C. We find the square root of what? Of both sides. So C here, we have it as what? Root 3. Now we can go ahead and begin to define parameters for sine, for 30 degrees, and for 60 degrees. Remember our SOHCAHTOA. From our SOHCAHTOA, we know that sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. So that I can conclude that from here, if you look at this triangle, your sine 30 is equal to opposite over hypotenuse, which is equal to 1 over 2. The opposite to this angle is 1, and the hypotenuse here is what? Is 2. Still on 30, cos 30 is equal to adjacent over hypotenuse, which is equal to adjacent to 30 is this side, that's root 3. That's equal to root 3 over 2. And tan 30, which is equal to opposite over adjacent, is the same thing as opposite is 1, and the adjacent is what? Root 3. 1 over root 3. Now, if you check your calculator, you see that sine 30 is the same thing as 0.5, cos 30 is 0.866, and tan 30, that's root 3 over 2, root 3 over 2, root 3 over 3 by rationalization. If you rationalize this solid, that will be multiplying the top by root 3, the bottom by root 3. That will lead me to root 3 over 3. Now, let's see that of 60. For sine 60, from this, we'll say that sine 60, the sine of 60 is equal to opposite over hypotenuse, which is root 3 over 2. The cos of 60, which is equal to adjacent over hypotenuse, 1 over 2. And at the same time, the tan of 60, which is equal to opposite over what? Adjacent. That's root 3 over 1, which is equal to what? Root 3, which is equal to root 3. So with that, we have defined for 30 and for 60.